Welcome to The Explainer. Today, we're diving deep into the hidden world of industrial automation. We're going to pull back the curtain on the tech that runs pretty much everything, from huge factories to the smart buildings we work in. And we're going to do it by looking at the one thing that acts as the brain for the whole operation. All right, let's start with something you can picture. Imagine a potato chip factory. One minute, it's churning out thousands of bags of tomato-flavored chips. The very next, without skipping a beat, it's making pudina flavor. How does the exact same machinery know what to do, when to do it, and how to switch on the fly, all without a bunch of people running around changing settings?
Well, the whole thing is like a perfectly timed dance. The system automatically weighs the raw potatoes, and based on that weight, it calculates the exact peeling and frying time needed. Then it shuffles the finished chips down the right conveyor belt and applies the perfect amount of the correct seasoning. It's this incredibly complex sequence, and it all just happens. No human intervention needed for each little step.
So, what's the secret? It turns out the magic is tucked away inside a pretty unassuming metal box. This is the electrical control panel, and inside it is the powerful brain making all of these split-second, complex decisions. And that brain is a special kind of industrial-strength computer called a Programmable Logic Controller, or what everyone just calls a PLC. Think of it as the ultimate adaptable employee. It's an open program device, which is a fancy way of saying it's not built for just one job. Nope, it's designed to be programmed for any custom job you can dream up. So you might be thinking, what makes a PLC so different from, say, the little computer chip in my washing machine? Well, that washing machine chip has its program permanently burned in. It's designed to do one set of things for hundreds of thousands of identical machines. A PLC is the total opposite. It's built for customization. Imagine trying to design a brand new, custom chip for every single client's unique machine. It would be crazy expensive. With a PLC, you can just teach it a new set of tricks. It's perfect for those one-of-a-kind jobs. So how does a PLC actually think? Well, it all boils down to a really simple but powerful system. It takes in inputs, it applies some logic that we've programmed into it, and then it produces outputs. Let's break that down with a super simple example, like a smart automated room. First, the PLC is constantly gathering data from its sensors. Think of these as its eyes and ears. In our smart room, it's paying attention to two inputs, a motion sensor that can tell if a person is there, and a temperature sensor. Okay, next, it takes that information and processes it based on the rules we gave it. In this case, the logic is a really basic if-then statement. The PLC is checking its list. Has a person been detected? And is the temperature above 40 degrees? And finally, if both of those conditions are true, it sends a command to perform an action, an output. And here's the crucial part. It's not just reacting to one thing. It's making an intelligent decision based on multiple conditions. It sees a person, it checks the temperature, and only then does it decide to turn on the AC. And this right here is where the true genius of the PLC shines. What if the next client wants the AC to kick in at a cooler 35 degrees Celsius? No problem. We don't need new hardware, we don't have to rebuild anything, we just change one number in the program and boom, the exact same PLC has a whole new set of instructions. It's incredibly flexible. But here's the thing, a powerful brain like a PLC, well, it doesn't work in a vacuum. It's actually part of a team, a whole family of different panels, and each one has its own very specific, very specialized job to do. You can think of it like a command crew. First, you've got the PCC, or Power Control Center. That's the main entry point for all the electricity for the whole operation. Then you have the MCC, the Motor Control Center. That's the muscle. It contains the starters that physically make all the motors run. Our control panel, with its PLC brain, is the director, telling the muscle in the MCC exactly when to start and stop. And finally, you have this specialist, the APFC panel, which is all about improving the quality and efficiency of the power itself. And that, as you're about to see, is way more important than it sounds. So let's talk about that last one, the APFC panel, because it solves a huge, and I mean huge, often invisible and very expensive problem. What if I told you that a factory could be wasting, say, 20% of the electricity it pays for every single month, paying for power that it literally can't even use? Yeah, it all comes down to this really important concept called power factor. The easiest way to think about it is like a grade, from 0 to 1 on how efficiently you're using electricity. A perfect score is 1.0. That means 100% of the power you're pulling from the grid is doing actual, useful work. The math here is simple, but the financial hit can be massive. If your factory has a power factor of 0.8, it means you're only actually using 80% of the power you're getting billed for. That other 20%? It's like ghost power. You pay for it, but it does absolutely no work. It's just pure waste.
In fact, the utility companies care about this so much that they actually build penalties and incentives around it. The difference between having a poor power factor and a really good one can mean a staggering 14% swing on your electricity bill. You can either get hit with penalties for being wasteful or actually earn discounts for being super efficient.
So what's the main culprit here? In pretty much any factory, it's the motors. They create something called an inductive load, which drags that power factor score down. This is where the APFC, the Automatic Power Factor Correction Panel, swoops in like a superhero. It is constantly monitoring the system's efficiency score. The second it sees that score drop, the APFC intelligently adds capacitive loads into the circuit. It's kind of like adding a perfect counterweight to a seesaw. It just balances everything out and pushes that power factor score right back up towards a perfect 1.0.
Okay, so we get the tech, but how does all this go from being an idea in someone's head to a real thing on a factory floor? How does a custom panel actually get designed and built?
Well, it all kicks off with the client. They provide what's called a load list, which is basically just an inventory of every single motor the panel needs to control. From there, the engineers calculate the total amount of electricity needed. They use that number to size every single component, from the main safety switch to the thick copper or aluminum bus bars that carry the power inside, always adding a good safety margin. Only after all that is done can they cost out all the individual parts and create the final quote.
But for the really complicated projects, like our chip factory, it goes way beyond just a list of parts. It becomes about understanding a client's entire vision for how their operation should run. They call it a control philosophy. And the job is to translate that entire philosophy into thousands of lines of perfect automated logic that can run an entire plant flawlessly.
And this is really where deep technical expertise has to meet business integrity. For a lot of clients, the most important thing isn't just the clever programming, it's trust. It's knowing that the high-quality, reliable components that were promised in the quote are the exact same ones that are actually going to be installed in the final panel. That's a rock-solid promise.
So, from the perfect potato chip to the efficiency of a factory's power bill, all the way to the air conditioning in a smart building, these electrical control panels are the unseen intelligence making it all happen. They really are the invisible brains running so much of our modern world. Which kind of leaves you with one last thing to think about. What other invisible brains are running the automated world all around you?